so that we can begin. I can see a couple of seats right in the front row, so please hop on to the ones who are sitting behind. So if I can request all of you to please come forward and please put your mobile phones on silent. So we'll invite. Okay, sir. Thank you. Good afternoon, ladies and gentlemen, and a hearty warm welcome to each one of you. I think I hope we've had good lunch, and we're all very energized for this very powerful session. Esteemed list of members are going to come right here on stage and share their thoughts, their experiences on this very, very powerful topic, and that is technologies required for manufacturing of an indigenous aero engines for Atmanirbhar Bharat. So yes, thank you. Firstly, thank you very, very much for joining this session. We're very, very happy to see all of you being a part of this session. The topic says, under the umbrella of Atmanirbhar Bharat, the government desires the nation to be on the manufacturing radar of every company in the aerospace manufacturing sector and move from generics to specifics. India is continuously growing in its power to indigenously design, develop and manufacture advanced cutting-edge technologies and systems in the defense. Yet, not much to be achieved towards manufacturing of an indigenous aero engines despite efforts in this direction. However, recently, Defense Metallurgical Research Laboratory has established the near isothermal forging technology to produce all 5 stages of high-pressure compressors disked out of difficult-to-deform titanium alloy using its unique 2000 MT isothermal forge press. This is a crucial technology for establishing self-reliance in aero-engine technology. With this development, India has joined the league of limited global engine developers to have the manufacturing capabilities of such critical aero-engine components. New technologies on the horizon have the potential to decrease greenhouse gas emissions from aviation significantly, and solutions being implemented today promise further savings. Enhancing capabilities of indigenous companies, including MSMEs, in innovative niche technologies towards development of an indigenous aero engines would be a step forward towards Atmanirbhar Bharat that the country is striving for. Thus, today's session is very, very pertinent to take this agenda forward. So without further ado, let's start this informative session. I will call all our speakers right here on stage. Of course, we have our SC Council, Co-Chairman, SHM National Council on Aerospace and Defence, and Chairman, SMPP Private Limited, right here on stage. Let's have a huge round of applause, ladies and gentlemen, for Dr. SC Council. Thank you so much, sir. Next up, Mr. Sohail Praveen Patel, Director, Subosha Advisory Private Limited. If I can request you, sir. Thank you very much. Please take your seat. Next up, Mr. Alok Nanda, CEO, GE India Industrial Private Limited and CTO, GE South Asia. Welcome, sir. Thank you very much. Next up, Mr. Florence Chauvency, Executive Vice President, Safran Helicopter Engines. Thank you so much, sir. Please. Next up, Mr. Alex Zeno, Executive Vice President, Business Development and Future Programs Defense, Rolls-Royce, to kindly come on stage. Thank you very much. Next up, we have Mr. D. Anand Bhaskar, Managing Director and CEO, Airworks Group. He will be joining us shortly as he's caught up somewhere, but we will see him on stage in a short while. Next up, we have Mr. N.Z. Siddiqui, Director, Gas Turbine Research Establishment, GTRE. Thank you so much, sir. So firstly, thank you very much to all our esteemed panel members to be right here on stage, and it is absolutely a pleasure to host all of you. So without further ado, it's time to invite Dr. K.C. SC Kansal to share the welcome address with all of us. Sir. Yes.
Good afternoon, ladies and gentlemen. As I've been introduced to by Kavita ji, that I'm the co-chairman, SHM, National Body for Defense and Aerospace. Today I'm here to welcome all my dignitaries and the speakers, honorable speakers, and the other members of the industry and the media. It's my pleasure to welcome Dr. Ajay Kumar, though he is not here today. Anyone is representative from Government of India, Ministry of Defence. I also welcome my three speakers from various industries supplying engines to our aircraft manufacturing units from UK, US, and of course the France. Sitting beside me, who is sitting in the dais. I also welcome all ladies and gentlemen who are present over here. Today, in fact, the topic is the engines for our airspace. In fact, it's a very wide and very sensitive matter today. We speak about manufacturing of aircraft, Tejas, and all this. Question is, what is that? What is the heart of this engine? And today, we'll be discussing who are supplying us and what is the perspective under Atmanirbhar Bharat and manufacturing indigenously, maybe with a joint venture or with the TOT or of its own, Indian industry of its own. Why? Because the need is there. Need is very much there. It's easy to say we are making Make in India, import substitution or Atmanirbhar Bharat, but what exactly is being done by the Indian industry, that is a question to be talked about. And what is the government is encouraging to us, to the Indian private industry, that has to be discussed. And what the government is giving facilities, the encouragement, that also be discussed. And what is industry looking for? Ladies and gentlemen, till today industry has shown, yes, the day it has been opened, Government of India has given us the negative or the positive list, which our Prime Minister, Honorable Prime Minister says the positive list. Fourth list is going to come out. Industry has given a very, very good response. Be it K9 Vajra, be it anything, be it any type of ammunition, the industry has come forward and given us very good response to the government call. Today, let us discuss what all the Indian industry can do, what all our foreign partners can do for the domestic manufacturing. This is what we have to do. Today, let's see. I open the house and thank you so much. Thank you.
Thank you so much, sir, for setting the contest and for your kind words. All right, now may I please request Mr. Sohail Praveen Patel to conduct and moderate the panel discussion. Over to you. Thank you.
Good evening, good afternoon ladies and gentlemen, and a warm welcome to this very crucial and important session on manufacturing technologies for aero-engines. We have with us a very erudite and illustrious panel who will share their thoughts on this subject. But before we view the thoughts of the panelists, I will try my best to provide an overview of what is happening in the sector of aero-engines in India. Aero-engine is one of the most complex systems on board any aerial platform. It has components turning at very high rotations per minute. They have to withstand very high temperatures, operate very efficiently from sea level to almost stratosphere level, and from zero to high supersonic speeds. Historically, the previous generation aircrafts have extensively used gas turbine engines. Over the years, gas turbine engines have incorporated increased turbine inlet temperature, increased compressor pressure ratio, increased bypass ratio, reduction of noise, and improved reliability. The new engine technologies will involve engine airframe integration, new and improved materials and material processing techniques, advances in turbo machinery technology, and progress in combustion technology. The future is that of also of green engines, which will look at improving engine fuel burn efficiency and reducing harmful emissions. Some of the design considerations include ultra-high bypass turbofans, open rotor engines, alternate fuels, and situating engines on aircraft's fuselage. moving from a component-based design to a completely integrated design. Electric engines powered by lithium polymer batteries and solar-powered manned aircraft that can fly any time of the day or night without refueling are already in the works. The combined Brayton cycle aero-engine and the multi-fuel hybrid engine are two novel engine designs currently being researched. Also, quick word on smart engines. Full authority electronic digital records controls for aircraft engines were made possible by advances in computer technology and the microelectronics revolution. The active controls at the component or subcomponent level within the compressor, gas turbines and bearings were the next stage. The smart engine has a massive amount of computing power. And when we talk about manufacturing, it is very natural and crucial to talk about MRO and its importance. All the engines would at some point require maintenance and repair. It is important to include MRO capabilities and infrastructure in any plan for true Atmanirbhar Bharat in the aero-engine sector. We cannot progress to manufacturing engines and then outsource MRO outside India. I'll quickly talk about the current capability status in India. I'm sure my panelists will have a better view, deeper understanding of the topic, but I will just quickly give an overview. So the aero-engine demand in India is met mostly by foreign imports and by state and defense companies working on under license manufacturing. HAL is the most experienced and competent agency in India when it comes to aero-engine manufacturing. DRDO and its labs GTRE, DMRL and AD are involved in R&D for aero-engine technologies. HAL's Bangalore engine division has manufactured more than 3,100 engines and repaired and overhauled more than 16,500 engines. DRDO's Defense and Metallurgical Research Laboratory, DMRL, has recently established the near isothermal forging technology to produce all the 5 stages of high-pressure compressors, discs out of the difficult to deform titanium alloy, using its unique 2000 megaton isothermal forge press. DRDO has also developed single crystal plates technology and supplied 60 plates to HAL as part of their indigenous helicopter development program. The Kaveri project also has helped India master some critical technologies, and the ecosystem is partly in place for basic design development, testing, assembly and manufacture. Of course, there are certain capability gaps. India will have to address these gaps across the product life cycle, beginning right from the engine design to the materials, the material technologies and advanced manufacturing technologies. And also a quick mention on certain lack of testing facilities that we lack for engine testing. Coming to the actual programs that are in progress in terms of engine development, HAL is developing the 25 kN HTSC 1200 turboshaft engine for multiple types of helicopters, the 25 kN HTFE 25 turbofan engine for trainer jets and combat drones, and a 130 kW engine for long endurance drones. Gas Turbine Research Establishment is developing a 46 kN Kaveri tri-engine for the combat UAVs. ADE is also developing a 1 kN turbojet engine for target drones, a 2.7 kN turbojet engine for air-to-surface missiles, and the 4.4 kN Manik small turbofan engine for cruise missiles. Hyderabad-based Research Center Imarat, again a DRDO unit that collaborates with state-run NAL laboratories, is developing a 275 kg force thrust small turbine engine for the homegrown Rustam 2 tactical drone. On the private sector side, Bharat Forge is developing a 120, 160, 200, 300, 400 kg force miniature and small turbojet engines. Additionally, a deep tech startup called Panian Aerospace has also recently designed a state-of-the-art 4.0 kN turbojet engine for cruise missiles and large UAVs. They are working on more engines in the 3 to 12 kN thrust range, using AI and 3D printing technologies to produce the engines. Coming to the demand side, we have the Ministry of Defense estimating that India's military aero-engine market will amount to rupees 3,50,000 crores over the next 2 decades, which means around 17,500 crores per year over the next 10 years. Recently, a panel of experts also came together to analyze and recommend the strategy for aero-engine manufacturing in India. This happened sometime in September time frame, August-September. The team found that India will require 1,000 turbine engines for fighter aircrafts and over the 2 decades, and 1,000 replacement engines for fighters, 700 for trainer aircrafts and 4,000 for 3 to 6 ton class helicopters and 1,000 for 10 to 13 ton class helicopters. I mean, that's a lot of engines. But now let us hear from our panel on how they envision on fulfilling this demand. I would like to begin by asking Mr. Alok Nanda from GE. Sir, since you closely work with internal and external partners in India on collaboration, innovation and IP, where do you feel we are in terms of capability and what are the challenges in aero-engine manufacturing in India?
Can you all hear me? Yeah. Okay. So, we've been, GE is in India for last 120 years and our technology center is in India for last 22 years. I actually started in DRDO and joined GE in 2000 when our technology center started in GE. And we've had a good rich history of working with almost all aspects of the ecosystem in India. Many of you know about our technology center. It has about 6,000 engineers, 1,000 of them have been worked for aircraft engines. And the latest engine that GE is designing, GE9X, almost 70% of GE aviation team for that engine is in India, where we have done from conceptual design to certification for the GE9X engine in India. Now that's within GE. Now if you think about ecosystem beyond GE, we have tremendous partnership with IIT Madras, who we have found to be really fantastic partners in the area of combustion, also in the area of dynamics, in the area of machine design, where we developed a fully grown micro turbine recently designed, developed, tested with IIT Chennai and tested with National Aerospace Labs. So we've had a very good relationship and benefit of utilizing various aspects of ecosystem in India. We work with startups, we work with DST very closely, we work with, as I said, NAL almost on a regular basis, working with them to design and validate some of the components and subsystems that we develop. So, in my view, we have an ecosystem in India which is now ready to do whatever it wants. Coming to the manufacturing part of aviation engine. So what GE has in India today is, one, we have our multimodal factory in Pune. What it does is mostly engine externals, but we also have a collaborative factory with Tata's in Hyderabad, which does structural components like casings and all, which I think puts us on a path of creating whatever we wanted to do. But having said all that, then what is the issue? Why are we all here? What are we what is stopping us to do whatever we wanted? And I have 3 basic points to talk about that. And so can I do it now? Yeah. So one of those, I have divided it. So I was thinking in the morning what I will talk about, okay? Because I'm sitting next to my friend who is my senior from GTTC. We've all come from the same stable. And in the audience, there are several people who I have studied with. So you know, there is no problem there. We have the talent, we have the capabilities. You talked about Medhani and DMRL and all that infrastructure. HAL has the biggest infrastructure. What are the 3 things we need to work on is what I was thinking in the morning, and I divided it into 3 parts. One is some of the more foundational things. If I compare how research happens in US, how research happens in Europe, and how research happens in India, if you think about India spends a lot of money on research, US spends a lot of money on research. The biggest difference is that in US, when you do research for, say, the latest and the greatest acoustic technology, which will be going into our next generation engine, we've been working on it with NASA for last 20 years. So NASA has been investing, GE has been G will now put it into the product. So NASA's job is to industrialize the technology. G is the industrialization engine for US government in that respect, and because G is commercial, we industrialize it in a manner that actually then is sustainable because it makes money. Now if you think about in India, we have the best of the best national labs, we have the best of the best industry, we have the best of the best academia, and we have the probably world's best startups. What is the problem is not getting them all together to have one aim as to now industrialize the product, and every one of them in their own regard are working very hard. I just hope as an engineer and as a citizen of India that we someday can get all of them together with the aim of industrializing the technology and not developing the technology, because physics is not enough. We've seen that. Knowing physics is not enough. We have to have an industrialization which has to be based on commercial wins for the country. So that's number one, foundational aspects. And in those foundational aspects you can add, okay, now materials and everything, and from low TRL you need to get it to industrialization. That is point number one. The point number two that I have is technology. So we have like fantastic systems where we mature technology. We follow the TRL method, and we have our own method, the DDR, CDR, PDR kind of approach, a very good design tollgate based approach. We don't have a parallel MRL system, which is a manufacturing readiness level, which needs to go hand in hand. As I said, physics is not enough. We need to do a technology. I'll tell you one example of G. 30 years ago, we embarked on developing composite fan blades for our G90 engine. Okay. Some of there were a lot of memes at that time around, okay, how can G introduce plastic? And when we actually matured that technology, we put it on the engine. It was 30 years ago. Okay. Nobody else has a composite fan blade in an engine which is a commercial engine. Now, our scrap rate for the fan blade was 98%. Anybody else would have given up. Any other industry, it can bankrupt you if you have that kind of a scrap rate. But then you work together, you work along with this quad that I mentioned, where all of the society comes together and then takes it forward. And now it's the biggest success story. Not only it is the most reliable fan blade ever made, but it is also something which is kept in New York Arts Museum because of its shape and because it's so aerodynamic. It's almost like a piece of art. Now think about a CMC technology, ceramic matrix composites technology. It took us 30 years to get the first CMC part on an engine which is flying. 30 years. I see a lot of people talk about GTRing and their success and other things. Do you realize that, okay, one technology 30 years, GTR has been existing for 30 years. So we should know how to put people up and when not to poke holes into the technology. 30 years for CNC technology, first part in. Almost entire research was, majority of it was funded through funds which were not GE funds, which were like US government agency, some of the other agency funding. That's something that we need to bring forward. Technological challenges are not technological challenges that we don't understand physics. We can teach physics to anybody else in the world. Probably we do today. I think it requires a validation engine to go hand in hand with an understanding that these things take time, and then supporting our efforts to get to where we need to get to. Okay, so that's the second point I have, which is around technological challenges. The third point is commercial. I see a lot of times we say, okay, now we talked about thousands of engines that we are envisaging in India, and probably that's true. At least that's our intent. Now you ask a company like Tata or any other industry, a profit-making company, to say, okay, now we have 2,000 engines coming up, will you put up an industry for this thing? I think everybody will sign up for that. who creates that business? At least I have never seen it translate into that. Everything is a pipeline. A pipeline is not a business case, and we must acknowledge that that's what it is in an aircraft engine. Aircraft engine is the most complicated product that mankind has ever designed, which has very low volume as compared to say cars or anything. So when we think about, so I think government needs to intervene. It's out of question for just hoping that an industry will put up the latest and the greatest plans on the basis of the pipeline when we don't have a business case. So those are my 3 points. I think first one is more foundational. Let's get this squad together. Let's get industry to be the industrialization partner. Let's do technology development for industrialization, bringing all the elements of ecosystem together and with adequate funding. If we can integrate partner funding into this, much better. Okay, that would be awesome. Now, technology side, as I said, we have to face into the issue that we might have 98% scrap rate if we are doing with something which is bold. I think supporting the team which is doing that at that time and not putting them off and calling it a failure, not being able to get it right first time in an aircraft engine industry is not a failure, it's actually a success, because you learn and you move forward. So that's something we must understand, that understanding physics is not enough. And the third point is around commercial aspects. It is a complicated product, high risk product with very low volume. If we don't understand that, if we don't invest for that, if we let the industry only do it from a profitability point of view, we will never make progress. So those are my 3 points. Sorry for taking some time, but that's what I feel.
No, so there was some very important points that you made, very valid. Next, I would like to call upon Mr. Flora from Safran Engines. So the Indo-French relationships are quite close and should help French aerospace companies develop high technology business in India. How has Safran helicopter engines journey been so far in India, and what are the future plans according to you?
Okay, good afternoon. Thank you for hosting me. Good afternoon, everyone. So the journey so far has been quite good, I would say, and we've been having a collaboration with the Indian aerospace industry as well as the Indian armed forces or civil operators as well for more than 60 years. It started with the R2 engine, a whole hydraulic engine on the Cheetah and Cheetah 60 years ago, like I said, and moved on progressively over time up to the Shakti engine, and then there's more to come. But basically, time after time, the relationship has evolved. It came from a repair license, with HAL on the R2s, up to co-development and a large transfer of production on the Shakti. And moving forward, I guess we will discuss it a bit, onto a strengthened partnership with HAL. Basically, and now I think one of the key elements is also the, I try to spell it right, the Atmanirbhar Bharat spirit. The relationship of Safran helicopter engine is really into that spirit and trying to strengthen this relationship with the Indian aerospace industry and mainly HAL.
Thank you so much. One or two more questions for you. So Safran NG recently signed a co-design and co-production MOU with HAL for the IMRH engine. Can you help us understand how this helps India to develop capabilities for aero-engines?
So that's really in line with what I was saying earlier. License for MRO on R2s, production license on Shakti, and now really what we're moving into is a joint development, a 50-50 joint development with HAL through a joint venture that actually will be the vehicle to develop, produce and sell this engine, and of course support the engine on the Indian soil. So basically the engine will be assembled in India, will be supported directly from India. And what we're talking about is, like I was joking, but the Artus is like a whole hydraulic engine. Now we're talking about a state-of-the-art engine for a power range that actually doesn't exist in the market. So we're really developing the high-end technology, the best we can do for the helicopter market and that category of helicopter.
Thank you so much. One last point, sir, from you. For the Army globally, it is important that the MRO facilities are very critical and under its control for sustenance. You also recently announced a new helicopter engine MRO facility at the Goa plant earlier this year. So how will this help the Indian stakeholders from an MRO standpoint?
So today, thanks to the different engines that I talked about, we have roughly 1,500 engines, either fully developed by Safran HE or in partnership, and that does not include the Ado that we have with our friends from Rolls-Royce. But the idea of that JV is actually completely in line with your question about availability. It has to be on the Indian soil. So that's why we've decided to put together with HL like a 50-50 joint venture to support this engine and bring the best of the best in terms of support. Just as a matter of information, this year we've been ranked first in the surveys on the helicopter market. So what we're bringing is our expertise, and together jointly with HL, we're putting that into form through a joint venture in India to support very closely the Indian forces.
Thank you so much for your thoughts. Now we move on to Mr. Alex Zeno from Rolls-Royce. Sir, in the defense sector, a much often heard term is technology transfer. How do you as Rolls-Royce view this, and as a country in this, is this sufficient to enable a robust defense ecosystem?
Hello? Yeah, that's right. Good afternoon, and thank you very much for the opportunity to speak here. It's a pleasure to be alongside industry colleagues and the Indian Aerospace and Defence Council. In terms of that question, I guess I want to approach this in three batches. But before I get to that, I guess from a Rolls-Royce, similar to my colleagues in GE and Safran, we have a history in India that has built up over many decades and has started. If you take the life cycle of an engine from that R&T through to support, has more or less gone from right to left. So we started with that support, an MRO, started with the licensing then of manufacturing, assembly and test, moved back into component manufacturing. So what I'm going to talk about is what I think is the natural next step of moving back into that design and development phase and for the final bit of the life cycle. And I think there are three areas in the way I thought about this. One is collaboration, and I'll talk a little bit more about that in line with the transfer of technology you referenced. Second bit is infrastructure, and then nothing really in industry is able to happen without some of the policy changes, and my colleague touched on that from an R&T, but also from a broader industry perspective. So transfer of technology, I guess India over the past few years and decades has developed capabilities through indigenous design and development activities at GTRE, at HAL. Experience and knowledge has been built up through programs like the Aero-engine, the Manik, the Hindustan turbofan engine, turboshaft engine, to name just a few. So clearly that, alongside the licensed manufacturing contacts that they've got with Western and Eastern origin engines and component suppliers and partners, has given them actually a great foundation and an ecosystem in the country. But when you talk about the next generation, the question of how do you manufacture an indigenous aero engine, To me, it's about accelerating that. My colleague talked about R&T and developing capability. Any country can get there over 40, 50 years plus. So the question for me then is how do you accelerate that? And we would talk about the move from transfer of technology to transfer of capability. And in our eyes, in my eyes, that is subtly different. The primary difference between those two is around the mechanism of intellectual property generation and the ownership of that. So the transfer of capability isn't just about sharing tools, it isn't just about sharing processes, it isn't just about sharing skills and training systems. It's about, and that know how you do it, but also the know why. And that's a fundamental difference in terms of that transfer of capability to accelerate the indigenous aero-engine manufacturing in the design and development space. Because if you own that intellectual property within your shores, you have control of how you use that intellectual property and how you accelerate the manufacturing of it. And it enables partners in India to build and the required skills, the required infrastructure, and use not just on a single engine, but use then across potentially multiple engine types in the future, and provides that self-reliance, the Atmanirbhar Bharat that is very clearly the desire and vision in India. But there are varied degrees of maturity across the engine and aero-engine life cycle in the Indian ecosystem. And I think, as I've said, the need for that collaboration, I talked about collaboration being my first point, collaboration in those areas of design and development, testing and certification, and manufacturing in the production area are three of the areas where I would put out there a hypothesis that through collaboration, those areas actually in terms of capability can be accelerated and get to that outcome a lot faster than doing it all within a pure R&T over time perspective. And by doing that, clearly you can do the two in parallel. You can share technologies with your collaborative partner in terms of ready de-risk technologies and then develop that design, development capability, that manufacturing capability, certification, knowledge and integration, while in parallel doing the R&T to bring that up alongside across key areas. So that's the point for me about collaboration, the opportunity for India, for its acceleration of capability over time to collaborate with third parties. Then there's testing, and clearly testing comes in many forms and in many areas as well, and this is the infrastructure bit. Clearly you can have engine testing, you can have altitude testing, you can have component testing, module testing, all the way down to materials and the details. But these are capital intensive areas and investments because yes, you can bring up the skills, you can do the work, but you need that infrastructure to enable that capability. So again, collaborative approaches, either with other countries or third parties to share that capital investment, or to determine, classify as a strategic requirement for that self-reliance. Again, an important part in terms of setting up self-sufficiency and some options there. Around manufacturing then, again, an opportunity both from an infrastructure and a collaboration. This is where the two come together in maturing some of those processes to really improve the manufacturing capability. And ultimately, volume is a key part. Colleague talked about pipeline. Pipeline isn't an order, absolutely right. So again, looking at where some of these technologies from a defence perspective have dual use capability. And that's a key part of being able to make those investments valuable in terms of the business perspective and valuable in terms of the economic value to the country. Whether that's forging, casting challenges, whether it's special processes, machining fabrication challenges, those are some of the areas, powder metallurgy, forging, machining. These are some of the detailed areas that we see as areas of potential within India to move forward and to accelerate. And I said there was a third area, and that's policy. Clearly, Indian government has taken some massive steps to proliferate the manufacturing industry through tax reforms, foreign direct investments, SOPs for manufacturing units, liberalised that FDI as I mentioned, and many other stimulus. I guess additional levers that we would consider as areas to continue the conversation and continue to look at policy were around capital infusion. I've just talked about infrastructure and developing those capabilities and acceleration. The exchange of data between countries, especially in the defence realm. How does that data transfer? How do the security systems align? How do you enable that in a digital world? There are clearly structures, we talked about commercial structures between industry and between governments to enable that, and then skills. And I think that's a huge part, again, of moving skills between boundaries and between borders. So those are just some of the areas, again, we see as opportunities to work with the government of India to talk about how some of those policies can really help enhance and accelerate that roadmap to an indigenous aero-engine being manufactured in country. Thank you.
Thank you, Mr. Zeno. I had one more question. I think you've covered most of it, but I'll just ask anyway. What is Rolls-Royce experience globally of working on joint engine development programs, and what learnings can you share on that?
I think, Florence just mentioned, I mean, we collaborate on many engines. We collaborate on the Aero-engine, we collaborate on the EJ200 engine that goes in the Typhoon, we collaborate on the RB199 that goes in the Tornado, and in the transport market we collaborate with our European partners on the TP400 that goes on the A400 air transporter. So our experience of collaboration is deep and long in terms of its history. And I think there are a number of key factors of that. Aligning around a common goal, and that's really key part of any collaboration, is having that same vision, having that same endpoint. And then sitting down and ensuring you have a common set of requirements between you. Too often, time is pressure, and people want to accelerate through those early phases of a program and don't necessarily capture those requirements, they don't necessarily capture those key assumptions. Further down the road, you find that comes to bite you. And that can be a challenge in terms of spending that time in that early phase of understanding your vision and understanding where you want to go. And then understanding why you're collaborating. Are you collaborating because you want to access technologies between you? Are you collaborating because one wants access to market and another wants access to technology? What are the rationale for that collaboration? So those are just some of the areas, I think, common vision, common requirements, and understanding why you're partnering and what the outcome you're looking for is key. If those aren't aligned up front, you're really travelling hopefully.
Thank you so much for those inputs. I think Mr. Anand Bhaskar, I think from Airworks, is a bit delayed, so we were hoping that he would give his perspective on MRO and the combination of civil defense MRO within India. I think Mr. Zeno also spoke about what he expects from the policy front. So if any of the other panelists have their views on policy in terms of what they would like to see in terms.
Not exactly in terms of policy, but I would like to continue where Zeno left from collaboration on engine programs. I mean, especially when somebody from Safran and GE are sitting together. The best, the most successful commercial collaborative engine ever worked on is CFM by any standards. And I think it happened because, as I told you, any engine requires a market for a business case to be successful. And for anybody to invest completely on themselves, sometimes it's difficult. So a partner is good. Again, common goal, as Zeno said. And the partnership of CFM is very unique because it's not on the basis of, okay, I teach you anything or I learn from you anything. It's about, okay, you do this part of an engine, I do this part of an engine, you have this part of the market, I have this part of the market, everybody wins. And I think that's a very unique way of collaborating. So I thought, since we were on this this topic, and we are in the process of thinking of how do we collaborate to accelerate development of engines in India. That's a model that is the most successful model in aviation history. And now aviation is such a world where someday you compete with the same person, and on some other day you collaborate with the same person. And I don't know if you know, we have an engine that flies A380s, which is a collaborative engine with, can anybody guess, Pratt and Whitney. Did you know that GE and Pratt and Whitney collaborate for an engine that flies? So, and we are like fierce competitors. So there is collaboration is not something unheard of in aviation industry, because I said from commercial angles, the business case on its own for any one industry is almost impossible. I just wanted to add to that, and that's why you see everybody is a competitor to each other, everybody is a partner to each other on some platform, and everybody is a supplier to the same person on some other platform. So this is a very incestuous industry where we live like all together, working, making the industry move forward.
Thank you for your thoughts.
And maybe if I can add, it's about risk sharing, you're right, but it's also about win-win opportunity, like a partnership and strategic alignment. Like when you talk about CFM from the beginning, GE and SNECMA at the time, or Safran Aircraft Engine, had a vision together and knew where they wanted to go, and even now, today, they are extending their vows somehow for another 30 years, and they know where they want to go together. And it's the same in any partnership. If you have the same willingness, the win-win collaborative approach and a strategic alignment, then you can do very great things. We have other examples. With Rolls-Royce, we had the RRTM joint venture, which has a great engine, has had a very good history. At some point, we decided to break it up. But just because actually we wanted that there was a different vision on what the helicopter business was on both sides, but it did not mean that it was not a successful partnership, because actually I think it was.
Great, sir. Those are some great inputs for the industry. I hope we get to see such partnerships built in India. And now I would, if the panel is okay, and we can take a few questions from the audience, if there are any questions. Does anyone have any questions for the panel? Then I would like, we have one.
The devil lies in details, and we have realized very Aero-engine. In fact, we have been using British engines for a long time. Aero transfer of technology was done to us. So many other issues have passed. So generations have passed. But all these people who are looking at the future of India and their company collaborations, what do you think are the challenges, and what needs to be done by India to make it successful? And how do you ensure that there is a fairness and transparency in the such collaboration? Thank you. To all these people, all the OEMs, because if we look at Safran, we have reached some level, but when you look at joint development, most of the people have a, they enjoyed the pinnacle position. Is it realistic for you to be sharing technology? Do you think that, do you see India as a potential partner for engine design and development? Because India has a very promising industry. We have manned aircraft, we have unmanned aircraft programs. Do you think you see India as a potential partner for joint design and development? Thank you.
So I'll try first maybe. So thank you for the question, it's a very interesting one. First, what I would say is it takes time. As it has been said earlier, you don't develop such an industry overnight, so it takes time and passions. To your question, do we believe in it? I would say I would not be there today if I was not believing in the Indian market. And you know, I've worked, if you want to know everything, 10 years ago I was in charge of the Ardit Shakti program working with HAL. And yes, I firmly believe in the potential of the Indian industry in the Indian market. But like I said earlier, it has to be a win-win approach for such an OEM like us. We're not going to give away everything and not get anything in return. You know, it's like, I'm sorry to be very direct, but if we don't win anything, why is it useful? Same as when we, GE and us, developed the CFM partnership. I would say GE maybe was used to develop a complete engine. They've partnered with us. We had probably value added together, and we've made an even better business case thanks to this partnership. So I would say you have to see it also both ways, not always as a technology capture, but as a way to develop the business in India, but largely speaking, so that everyone wins. I'm not sure it answered the question, but really I'm a strong believer in such a win-win approach. And obviously it takes time. As I mentioned, we started with the Artus on repair license, transfer of production, and now we are in a 50-50 joint development on the IMRH, which shows how over the time we've progressed and gained in maturity in the partnership, but as well as in the competencies of both partners.
Yeah, sure, sir. Mr. Zeno.
Just to add to that, I support everything Franz says. I think when you look at India and where it is geopolitically at the moment, that you can clearly see India growing in the global stage. And when you talk about partnership, as everyone's talked about win-win piece, from our perspective, I guess there are a couple of things. One, there's a talent, there's a skill base here. And if you look at some of the challenges we're having, I'll talk about it from the UK right now and from a Rolls-Royce in the US, access to talent is in short supply. So I think there's a huge win-win in terms of access to talent here and the engineering volumes and graduates that you have both in the system and they're coming out of the system every year. So I think that's a huge partner opportunity of how you share that talent. I think actually in terms of where India is in its economic cycle and its development across many sectors, it's got capital. I think it's clear in some of the Western markets that's coming at a premium in the current environment. So access to capital here, clearly it's got to be, as my colleagues have said, capital that gives you a return. And I think that's the opportunity in the partnership. If we can access that talent and access that capital in exchange for capability, not just transfer of technology, but transfer of capability, there is a business model there. But I think the innovation is as much in the business model as it is in the technology to actually make that work. But that's the partnership opportunity.
Thank
so
you.
there are various aspects of your question, actually, a pretty deep question. The first part of your question I thought is, okay, do you really believe in India's growth? I think there is no question about that. The fact that all the three companies are sitting here, the fact that we've been in India working various aspects of Indian economy, boosting various aspects of Indian economy and taking like win-win from that growth situation. I think there is no denying either geopolitically or from economics point of view. I think people believe and want India to grow and partner India in growth. Your second question was, okay, if India partners with MNCs, do MNCs only want money or they want to give something also? Now the fact, there are two sides of this coin. Okay? The fact is making money is not a bad thing. people are in this area to make money, and then of course winning is defined for a corporation in terms of various aspects, and money is one of the critical aspects of that. So I am 100% sure that whenever any company is coming and having that discussion, at the back of it is their business plan, looking at India's growth and tying their own growth to India's growth in some manner, so that it is a win-win that gets created. So there is no denying that of that aspect also. Another aspect of your question was that will you be transparent, will the companies be transparent and actually collaborate or co-develop or share, or will it only be on paper? That I think is the most crucial part of your question. And I'll answer it in two parts. One, if you think about an aircraft engine industry, okay, the moat, the moat, there is a fort, and outside that there is this water path. Why people created moats? So that the fort is safe. So for an aircraft engine industry, IP is the moat. Because, and some IP is a stronger moat than some other IP. Some IP is the crocodiles in the water. And hence the whole premise of somebody not overshadowing you and you not creating a competitor or giving an advantage to a competitor is through a moat. Moat is critical for this industry. And hence, win-win is very important if you want to share the moat. Okay, that's an absolute fact, and I'm not right now talking like GE. I'm telling it to you from what I see sitting in these discussions and wishing that they move forward, but they don't, because everybody wants to protect their moat while they make money. So will it actually happen? It can only happen if you have a partnership which is win-win, which has the same strategic goal. And I think that is very, very, very important to understand. Because, as I said, it took 30 years for GE to develop a CMC technology with a lot of US taxpayer money. And hence, if you want to share that moat, economy is not the only thing. You have to have that trust in the partnership that actually allows you to do that. It's a hard fact. We can have a long discussion on this topic. So I hope we together, the three of us, answered your question. But it is a very important question that you ask. And when you say that, okay, will we get our fair share? I think defining fairness is very difficult in these matters. And that's why it is taking time, that's why it takes time, that's why it takes discussions. Because everybody looks at fairness in a different way. Okay, somebody is looking at fairness, okay, I invested 30 years to create this technology. Now, should I give it away, or should I have enough reason to share it and co-develop it and co-create it? That is why I emphasize on the point that we have to get the foundations right in our country. Because, we have to start creating our own moats. Where when we share, we say, okay, you give us this technology, we give you this. And then it's the real moat, and it's the real collaboration, it's the real win. Until that time, we have to make do with whatever opportunities and collaboration we have. But moats are important for this industry, and we must realize that. There is no question about it.
Great, thank you sir for that great analogy. While we've heard the OEMs and their thoughts, Mr. Siddiqui sir, if you had any comments to what they've already had said before you give your address, then please you can share some thoughts before.
Good afternoon, fellow panelists and esteemed audience. I will address most of the issues when I am just giving this talk. Very complex technology, thanks to Mr. Alok Nanda. He told why complex we all know. Extreme pressures, extreme temperatures, and these are not one-shot devices. 2,000 hours, 4,000 hours of operation, depending on whether you operate on the cold end of the engine or hot end of the engine. Rotors operate at speeds above 15,000 revolutions per minute. with finite clearances, 0.2 millimeters, maybe 2 times the thickness of the hair. When a machine runs with those kind of close clearances, not one stage, multiple of the stages, you can understand the complexity. That in fact makes this task very challenging. Over the next 10 minutes or 15 minutes, the time what had been given to me, I would like to give an appreciation of the gas turbine engine design and development through the flagship Kaveri program, what we had gone through. What is the current status? What is the future outlook? And more pertinent to the topic what has been given today, manufacturing technologies for the Aero-engine for the country to become Atmanirbhar. I will try to touch upon these points in my own perspective, and at the end I would like to make a few suggestions with the industry stalwarts who are here alongside me, and most of the time we had worked together in various of forums and various of discussions, more specifically over the last 5 years. With all these 3 engine majors, engine giants, GTRE had been working over the last 5 years, as I said. The need and necessity today, if you look at from the country's perspective, national level programs, flagship programs, be it you call it light combat aircraft Mark II, advanced medium combat aircraft Mark I, advanced medium combat aircraft Mark II, twin engine deck-based fighter. These are the national level aircraft development programs which are on the anvil today. In this kind of a scenario, it is pertinent, relevant and absolutely mandatory that the country looks forward to have its own combat aircraft engines flying these platforms. Hence, the need and necessity is unquestionable. How are we going to rise up to the occasion to meet this need and necessity? That is what perhaps over the next 10 minutes I am going to talk. And also to give to this esteemed audience a view. Most of the things may be opaque, what goes on behind the curtains and what the stage at this point of time the country is in with respect to the design, development, manufacture of the gas turbine engines. To bring more clarity, I would, though it may not be a universal definition, please pardon me for that, I will classify and categorize the engines as low thrust engines, medium thrust and high thrust engines. Low thrust engines I will define as engines from 5 kilonewton to 25 kilonewton. Medium thrust engines 25 kilonewton to say 80 kilonewton. High thrust engines going up to maybe 175, 180 kilonewton. I am purely talking from the combat engine perspective. Now, as a country, if I look at, with respect to the small turbofan engines, since the topic is more for the manufacturing, I will now not talk much on the design and development. I may here and there translate between design and development and manufacturing. If you look at 2 major engine programs in this thrust class of engines are either under progress or are at a very mature stage. To talk about gas turbine research establishment, small turbofan engine, which the panel moderator mentioned for the cruise missiles, GTRE has designed, developed, and today the engine is undergoing experimental flight trials. Fairly good success in 2 flights what we had carried out, partial success though, but then we are very confident and we are very sure we will be able to make that engine operational, no doubts about it. Now, if I look at that engine from the manufacturing perspective, totally 9 engines have been manufactured, development engines, which underwent a lot of development tests along with certification tests. 5 engines were completely manufactured inside the prototype fabrication group of GTRE. 5 engines. By value, the indigenous content is 90%. 10% with respect to some of the parts which are available from multiple sources we have imported. We have built the engines, the technology what we acquired we have passed on to the industry, we worked alongside the industry. Today, many of the tier 2, tier 3 companies, MSMEs, small industries have graduated to a point of manufacturing all those components. The 3 engines which went for the flight trials all have been manufactured by the Indian industry. In fact, BrahMos Aerospace Thiruvananthapuram Limited has emerged as a lead system integrator, and we did the hand holding in order to build these engines. So the bottom line what I am making is, with respect to this class of engines, yes, we are there. Country is largely self-reliant. Be it in terms of the static structures you talk about, or be it in terms of the rotating structures for the technology levels what we are speaking. Now if I move on to the medium thrust class engines up to 80 kilonewton thrust class, indigenous effort, Kaveri engine, nation's flagship program. Once again, I would like to give an appreciation for the kind of technology complexities what my co-panelists brought in. In order to develop one technology, you name it CMC, you name it BLIS, you name it single crystal, graduating them through the multiple generations, you talk decades. Even for OEMs with more or less infinite resources, if I may use that term. In the country, in 30 years, we had been able to design, develop ab initio, a 80 kilonewton thrust class engine, and the engine has underwent flying test bed trials, altitude testing, and whatnot. Just for that all elusive flying that engine in the LCA Tejas aircraft, the engine has done everything else. It is no mean achievement for a country to make a combat aircraft engine just short of that ultimate goal of flying in the parent aircraft, completing all the certification requirements. We understand in GTRE the nut and bolts of that design. Pure indigenous effort. Coming now to the manufacturing aspect of it, 70 to 80% of this engine, if I can call this as a 4th generation engine, we are able to manufacture through the Indian industry, in the country. Again, the components, sub-assemblies, assemblies were manufactured inside the prototype fabrication groups of GTRE, and subsequently we have handed over this technology to the industry, and today I am happy to share 5 new engines what I am going to manufacture in the next 4 years for a derivative engine program for a RPSA, remotely piloted strike aircraft. The Indian industries have been given contracts where they are evolving as module developers. An engine typically comprises of 2,000 varieties of parts and 20,000 components. When the engine operates, it is like a symphony. All these components have to talk in harmony if you have to have the outcome of the engine test results coming handy. Now today, 2,000 varieties of components have been broken down to modules, and 5 contracts only are getting placed with the Indian industry. That is the stage what we are in with respect to the mid-thrust class engines. Of course, now it is a different ball game when we come for the next generation engines. Engines which I classified as high thrust class engines. Engines upward of 90 kilonewton, 95 kilonewton. Even there, as a country, if I assess and give my perspective, my esteemed panelists will agree, 60%, it's my assessment, open to debate, open for a brainstorming, 60% of the components are common. When I say common, the technologies what you have developed for small engines, medium thrust class engines still apply. The basic machining processes don't go away, be it turning, be it grinding, be it milling. Most of the state-of casings, they can be machined. Where the difference comes? What I will do is just to give a perspective, since the theme of the presentation is manufacturing technologies for the indigenous engines, I will try to walk across the engine modules for these high thrust engines. Fans and compressors, I will classify them as compression systems in a global perspective. If I look at that 40% of the technology which in my view, which we need to develop inside the country, if I talk with respect to the compression systems, static structures, if I talk about casings, certainly we can do. When we talk about frames, which are structures which support the loads, which houses the bearings, the rotor loads get transferred through these structures, what we call as intercase frames, inlet frames, exhaust frames, and things like that. Today, the technology is moving towards from fabricated structures to investment cost structures. A humble beginning we have made. What I mean by that is, as a country from GTAD, PTC Industries, they have set up the infrastructure for the investment casting, large investment casting, and we have placed a development contract and we are progressing ahead. I am not saying that we are at a MRL level of 6 wherein this technology can go into a product, but you have to make a beginning. We have certainly made a beginning. Maybe we are at this point of time at TRL2, but it is another 3 to 4 years we will graduate. Similarly, if I now come to the rotating structures, up to 4th generation engines, typically you have discs in which individual blades are assembled. When you talk about the 5th generation, next generation engines, you talk about the blisk technology. 2-3 aspects here. One, starting from the forging. If you have to machine a blisk from a forging using a 5-axis CNC blisk machining center, you need to have a forging of the diameters of 800 millimeter to 900 millimeter. The requirement for having that kind of a forging in super alloys, be it titanium or nickel cobalt super alloy, you are talking about a hydraulic press of 40,000 ton capacity. Today, country does not have that infrastructure. In the absence of that, we are trying to do certain of those forgings procured from abroad at this point of time, and we have set up in GTRE a 1 meter diameter 5-axis CNC blisk machining center with which, starting from the steel material and subsequently in titanium, we have machined the blisks. You may ask me, is machining the blisk from a forging is all that? Definitely not. It starts right from the design. Once I move away from a bladed disc to a blisk configuration, the damping which is available between the blade to the disc goes away. The friction damping goes away. Aerodynamic damping plays a major role. How do I design? Yes, that is a technology in itself, but I am purely talking about the manufacturing technology. Yes, we have the infrastructure, we are doing trial machining of the blisks. Now, if I talk about the combustors, next take a fright about the engine, but it is a matter of time. The learning curve is more or less at its cusp. It is now time to deliver and we will deliver. Coming back again to the theme what had been given with respect to the turbine systems. Hot-end component, single crystals, panelists mentioned very correctly, our sister laboratory, Defense Metallurgical Research Laboratory. Yes, it took time, but we are able to make and deliver single crystal castings for high pressure turbine, blades and vanes of Kaveri class, a 80 kN thrust engine. To get a single crystal of that blade size is not easy. Today the country has graduated to that stage. Yes, yield rates, you have to improvise, no doubt. That comes over time and it will happen. And similarly, if you talk about the electron beam physical vapor deposition coating, infrastructure we are trying to set up, and powder metallurgy tests, be it in turbine side of the engine or on the compressor side of the engine, powder metallurgy discs. Hot isostatic thermal presses have been set up both at Midani as well as in DMRL, and up to 300 millimeter powder metallurgy disc we are able to make. Now non-metallics, if we talk about high temperature polymer matrix composites. We are in an advanced stage in terms of realizing for Kaveri engine a bypass step of that class of engine, and we are at a certification level. CMCs, we are at a very low MRL level at this point of time. The efforts are being made. So now, with this kind of a background, the point I am making is that the country is pretty much there in order to assimilate, absorb, if the technology with that strict dictum comes with know-how and know-how. Mr. Zeno very correctly mentioned, it is not just technology transfer, it is the capability transfer what the country is looking for. We are there, and hence, if we are going into a collaboration, that is the mode in which we will collaborate. Having said that, having given this background, a few suggestions for consideration. One of my esteemed panel speakers mentioned, I think Mr. Alok, tightly integrating the R&D, academia and industry. What do I integrate for? This integration, vertical integration, horizontal, all this goes on. Why do I integrate? I integrate keeping a end product as a goal with all these pillars of the ecosystem joining right up front in the beginning in a consortium based approach, or you call by whatever mechanism mode you work and then deliver the product. Take the technology, nurture the technology, mature the technology. If we do in a very concerted way, certainly we will be able to achieve in this country. Now, one of my esteemed panelists mentioned about accelerating. Yes, today every product is asked for yesterday. We need to accelerate. We cannot talk about an engine development cycle time of 30 years, gone are those days. We are talking about developments in 8 years to 10 years kind of a time frame, even for very advanced engines. What can facilitate this? Certainly, collaboration through a co-development. A co-development, when I say, again, I would like to emphasize, with capability transfer of technology with know-how and know-why. That is the bottom line. You can certainly accelerate. So it is a message on the behalf of the country, on the behalf of GT, DRDO I am giving, and this had all along been when I am interacting with these engine houses. This is what I always like submit to them, and we look forward for that. Coming to doing a systematic evaluation and realistic evaluation of gaps in terms of the MRS. For any technology wherein you need to bridge the gap, do it and have a very systematic planning, bringing in the stakeholders and then doing it. Last but not the least, we need to in the country set up university technology centers and also innovation hubs. Innovation hubs in order for us to remain at the forefront of the technology, not doing technologies, developing technologies in a sporadic manner. There has to be a continuous upgradation of the technologies. So you set up innovation hubs. It could be part of a startup ecosystem or the academia joining hands in and whatnot. So these are the few thought processes what I thought. In summary, we are there. We are at the cusp of delivering things, and we will. And days are not far. Thank you very much for patient listening and sharing.
Yeah. So do we have any questions? We can still raise our hands. Yeah, we have one. Right. Excuse me. Right.
Hello. My question is to MC Siddiqui sir. Sir, hi. I am also a student of Masters in Political Science from Central University of Gujarat. Currently, there are lots of universities in India as well, those who are implement the defense and strategical studies as a matter of understanding defense and their activities towards the nation and the Ministry of Defense as well as. As well as in our university, there is also a Department of Defense and Strategy study. So I want to know that how you process that in the PhD. So how the topics related to the defense and the research topics are more relevant towards the India in upcoming phase. Hope you understand my question, sir.
The last part of it, if you may kindly repeat the last part of your question.
My question is that in current scenario, we are doing research papers and methods using for defense and analysis. We are doing some normative principles, not empirical principles. That we are doing analyzing of a steam engine or a jet engine. We are using the techniques that are older version, not in because of R&D and because of other methods also. So how you understand and analyze the methods we can use in research in academia, so we can do it more enhancing and perfectly in upcoming times.
Okay, so I will put it this way. Now if you look at there's a lot of encouragement which is going up, wherein a huge drive is going on with respect to having internships inside the R&D establishments for the students like you, who are the pillars of this nation. So, if you today look at in the last 2 years, close to about 500 students have come in GTLE taking internships. And similarly, the MTech students and the PhD students. So, when you come and join hands with us, when you work alongside us, apart from the kind of work what you are doing in a academic setup, when you come and join hands into your R&D establishment, it emerges. So opportunities are there, make use of the opportunity, and we are here to welcome you with open hands. So it will be a nice wedding which happens between the academia to that of like know what the R&D establishment does or the industry does.
One more I have. Yes. Can I have the mic here, please?
So, again back to all OEMs, helicopter space is gone. Safran is already occupied. So, do you think there is space potential collaboration with India? Second, so now question to Director GTRE. So they have a problem of economic or business case. Is there a potential for us or work out a potential business cum technology partner? If not, then what are the challenges? Thank you.
I presume the second part of the question was addressed towards me. So I will address the second part of the question, and my fellow panelists can answer the first part of the question. I mentioned the need and necessity from where it comes from. Does it make business sense? Business model that is for everyone to analyze and understand. I said today the country is on the anvil of developing light combat aircraft Mark II, AMCA Mark I, AMCA Mark II and 10BM. If I do a fair study even with 1.5 engines replacement over the lifetime of the platform, we are talking something like 1,000 engines in this country. Leave aside the legacy platforms, MRO and whatnot. Roughly translates in the next 15-20 years to close to about 1 lakh crore of business, even at a very, very conservative pricing of $10 million per engine cost. So that's all I have to say at this point of time. It is for others to evaluate whether the business value, business potential exists. For any country having been in this business, this much I can tell, it is a huge business potential.
Yes, one more. There's another question. Yes, the first question, if anybody would want to answer.
First question,
yes.
yeah,
Sure.
let me start that. I'll let my colleagues chip in. The gas turbine market is a significant market, and I think when you look globally, let alone in India, you can cut it in many different ways, whether it's a turbo fan, a turbo jet, or a turbo shaft, and they come in many different sizes and many different shapes. So while certain parts of the market might be considered, to your point, closed, I think there are still many addressable and open and addressable areas in the market, especially in India as well. When you look across all those different turbo shaft, turbo jet, turbo fan ranges, and you look at the volumes, as my colleague Dr. Siddiqui has just mentioned, there are still enough opportunities to be attractive. Stand fast, as I said, the need for an innovative business model to make that work in terms of the transfer of capability and that access to talent, access to market is still attractive in India for us in a number of those areas, and the access to capital.
Yes, we have one more.
Yeah, getting to know that collaboration is the key from all the panelists, and along with know-how and know-why. Can we execute this plan for AMCA engine? And what is the plan for AMCA engine is the first question. And second question is how industry can help us to be specific. Industry can help in AMCA engine development.
As I mentioned, in the last 4 to 5 years, very intense discussions are happening with respect to the design development of the next generation engines. When we talk about this class of engines with the technology complexity associated, it takes time. Now, I would at this point of time say that we are pretty close to that decision making. That is with respect to what is the way forward with respect to the AMCA engine, what you are talking about. Also, as Mr. Zino mentioned, though I did not touch upon, we talk from the perspective, since I come from the R&D complex, which primarily addresses the combat aircraft engines. I was restricting myself to that. And at this moment of time, we are not working on turbo shaft and turbo propellers or commercial fans. But the requirement of this country, if you look at these domains as well, and also the land-based requirements, it's phenomenal. And hence, it also in a way addresses your point. I was purely talking from the military perspective. If we also slightly move away and look from the civil perspective and marine perspective, quite a large market for this in the country. So, yes, we are working towards that, and hopefully it should converge.
Yeah, and we've not
So my second question,
not even started talking about sustainable engines, hydrogen, hybrid electric. You know, this industry is like almost at a cusp of transformational change. And so, I mean, don't look at it from a narrow aperture. At least we are not looking at it from a narrow aperture. And if you've seen a James Bond movie, never say never. Okay, and so everything gets open. So it's a huge industry, and look at it from the point of view of today, tomorrow, and for this industry, actually, this is probably the only industry which plans for 30, 40, 50 years. So there is a huge explosion waiting to happen in this industry. That's what I would say.
Any other question? Yes, we have two more. So we'll go with that gentleman first. Could you please pass the mic then?
This question is primarily addressed to the three OEMs here. With the kind of policy shift that's been happening in India with regard to the Atmanirbhar Bharat and the Make in India, how are your companies kind of reorienting your operations in India, and how are you kind of looking forward to the future, work in India from your perspective, and also the GTRE director, making use of this Make in India and the Atmanirbhar Bharat, where do you think you're going to position yourself with regard to your collaborations with other foreign OEMs in this regard?
The direct and simple answer is to graduate to become an Indian engine house.
Yes, we have one more. Okay. Anybody else?
Okay, so I think an opportunity to go beyond where we are today. As I talked about that transfer of capability through the life cycle from right to left, we see that as the opportunity is to move further to the left into that design and development space, subject to finding what we've talked about here, the right business model, the right market opportunity to actually do that. We will continue to deepen what we have, whether it's manufacturing processes through our joint ventures such as IAMPOL, that's already expanding and growing, deepening our supply chain interface into India through some of the capabilities in the wider ecosystem. That is naturally happening just by the nature of where India is going through its policy shift. So India in terms of a global supply chain for aerospace, in terms of partnerships where we're developing manufacturing processes, that will continue to deepen. The piece is moving further down that life cycle, and as Mr. Siki said, providing that capability and that collaboration is what we see as that next step in the evolution with industry partners and with the government. That has to be a three-way partnership and collaboration.
Sir, my question is to Dr. Siddiqui. So some of the technologies that we mentioned, which are probably takes a time and money in terms of developing those manufacturing technologies, which may not be backed up by sufficient business case for the few applications that you are talking about, but they may be definitely making India Atmanirbhar, but may not be backed up by the business case. So in that scenario, will you still go ahead and invest in those technologies, even if it doesn't make a business case?
Maybe I have to lean back on my own experience having grown through the Kaveri program. As one of the most important lessons what I learned was, unless you have a very sound technology base built, talking about a product delivery is a elusive goal. You have to develop technologies upfront, you have to mature technologies if you are going to talk about the product. In a technology domain, as technologists we know, when I invest, I am taking that kind of a risk. If I do not have that kind of a risk-taking appetite, more specifically with respect to the gas turbine engine design and development, we need not be in this business. Hence, we need to take those risks. We need to have that kind of a risk appetite. Even if it fetches, maybe like now I invest in 10 technologies, I succeed in 3 or 4 of them, phenomenal by even world standards. Hence, that should not deter us from investing.
Thank you.
If I can comment on this one, because it's an excellent question. Is it about only developing technology? Because we keep hearing developing this technology and developing this technology. And your question is actually the key one, is a technology you develop one day can be overdue 10 years later because other may come. So it has to make business sense. It's about, is it technological push or market pull? It has to be both. That's my view to your question, as well as to your question earlier on. What is the market? I would say, what does the customer want? But for us to develop a new technology, it has to have a business sense and to make a business case so that the technology you develop keeps growing up rather than just developing a one-time thing that actually is overdue 5 years or 10 years down the road.
Go ahead, sir. Please.
I will take just like, in the beginning what Mr. Alok mentioned with respect to the GE's experience of developing the G90 composite fan blade 30 years back. If you have noticed, he said the scrap rate was close to 98%. They could have left it off. They didn't. So that remaining 2% is the one. That kind of a perseverance is what makes these technologies to work.
So I'll give you a little insight into how GE develops technology, just to address your question in a more comprehensive manner. So as we've talked, okay, the end goal has to be in mind. Like even when our GTRE director is talking about technology development he's talking about technology development with a product in mind, with an aim in mind. Okay, that aim has to be there. And when industry talks about it, they call it a business plan. When we talk about it, at least there is a purpose to why you are developing it. Okay, so once that purpose is established, you start many things. It's known that if you take any futuristic technology, if you start 10, maybe you will be successful in 2. If you are really good, maybe 1.5, maybe something like that. That's the percentage, you know that is going to happen. So we have have this process before we announce that what technology will go into which NPI or which new product launch. We have this set of technologies that we mature, and we call it kiss and kill. We at low TRL stages, we groom a lot of stuff, but then we mature a few. You understand what I'm saying? And that is very critical. So first is investment in low TRL technology. We must do that. Then it's about technology maturation program, which goes hand in hand with MRS, which is manufacturing readiness levels, which go hand in hand with technology maturation. And then you launch an NPI in which you bring these technologies forward. So it's a whole cycle. So we have to have a purpose. We have to have this suite of technologies. We have to have a process in which we say, okay, this is one we want to invest in to mature more, and then you announce that, okay, you will take it into a product, and then the product becomes successful. So it's a game of technology maturation and manufacturing maturation, and then launching a product to be successful with that product. So that's how in GE, just to give you a little bit of an insight into how we work at a high level.
Anybody else? Okay, we'll take the last one now.
Yeah, my question is to Dr. Siddiqui. Yeah, you started with the classification of engines from low thrust, that is starting from 4 kilonewton. So there are certain engines which are lesser than that, and we understand that as certain private players, they should be entering into that business. But we often see that again some of the other DRDO labs are participating into that. So thereby, wouldn't it be better that at least this market of small engines should be left under the guidance of DRDO labs to the private players?
Yeah, certainly. Certainly, in fact, to the best of my knowledge at this point of time, lesser than say 3 kilonewton engines, DRDO or HAL at this point of time are not working. And as also the panel coordinator brought out, quite a few of the Indian private industry at this point of time are investing into this technology. I don't want to name the industries, but quite a few of them. Hence, there is a very clear distinction at this point of time. Engines less than 3 kilonewton, quite a few private players are trying to design, develop and qualify those engines for multiple applications. And engines above 3 kilonewton, I just took a ballpark number of 4 kilonewton engine up to 25 kilonewton engine. And now DRDO and HAL are working in various of formats, be it as a turbojet, turbofan or turbo shaft engines. So this kind of concept, it's more or less it is there at this point of time. In the last few years, this is the kind of development what is happening in the country.
All right, thank you so much. I think this session was absolutely a detailed one. So many questions asked and all of them answered by our panel members. So thank you very, very much to our session moderator, Mr. Patel. Thank you for conducting the session so wonderfully. And of course, all our panel members for sharing your information on this very important topic. And Siddiqui sir, thank you so much for the words of wisdom that you shared in between. Of course, it was my turn to call you here, but then you did it there. So thank you very much for all the words of wisdom. All right, now it's time for a very exciting moment. So there is a book release that's going to happen right here on stage. It is a book which is published by Asojam and in association with ENY. So if I can request all our panel members, all the dignitaries on stage to kindly stand up and we can do the quick book release. Yeah. Let's have a huge round of applause, ladies and gentlemen, for this wonderful initiative, book published by Asojam in association with ENY. Thank you so much for doing the honors. On that note, if I may request Dr. S.C. Kansalsar to kindly come forward on the dais and share the vote of thanks.
Yeah, ladies and gentlemen, it has been a wonderful session. It's a very rare session when all the questions are replied in a very scientific and commercial way, of course. Commercial factors also have been taken care of by all the industry. If I start, let me thank Dr. Ajay Kumar, Secretary Defence in the Government of India. Though he is not physically present over here, I am sure, as per his taste, he must be available on BC. He's a guy who has been favoring all the industry association very badly. He is the rather existence, if ever somebody has given, it is Dr. Ajay Kumar. I thank him once again, at least creating industry association in a big way. I thank the moderator, Mr. Patel. Let me see, I hope I am. Mr. Sohail Parveen Patel, thank you so much for giving a detailed input and the feedback and all the input for all my OEMs to give their presentations. And he asked very nicely and very valid questions, no doubt, but and valid inputs. And the answers, of course, the best answer. All the three, including Mr. Alok Nanda, he told all the problems. When you look at the grass is green on the other side, but actually when he explained all the problems, 30 years for CNC, and so many, like the rejection level of 98%, it's a big thing, how one has to cross. He has given really limitations, at least I was not aware of particularly, though I am a technical man, but he has really given us. Similarly, Mr. Florent Chaubussi, he has wonderfully given all the questions very nicely and taken up very sportively all the questions and given a very answer. Thank you, Mr. Alok Zeno. Thank you so much for the detailed feedback and the detailed discussion on the topic. Thank you so much. Finally, I really express my gratitude for my Indian partner, Mr. Siddiqui. What was done in India, I was not aware of. So far, Mr. Siddiqui, I was under the impression that Kaveri is made and is being operated only with the 65 kN. So far I had no knowledge, maybe the misnomer I had. Today you have really updated my knowledge. Thank you so much. Thank you for all the development we learned when DRDO. Thank you. And finally I thank SHM who has given us a chance to discuss all the things, especially Mr. Sharma, Mrs. Kavita Sharma. She has taken really a good pain to organize this in place of from SHM side. Thank you, gentlemen, everybody. Thank you, media, if ever there is there. Thank you. Thank you.
Thank you so much, sir. On behalf of ASSOCHAM, I would like to thank the Government of India, Ministry of Defence, Department of Defence, Production for giving an opportunity to ASSOCHAM to associate with this prestigious Def Expo 2022. I would also like to thank all our participants for their presence, and last but not the least, a big thank you to all our patrons for their unflinching support. Airbus, Boeing India, Lockheed Martin, Airworks, Big Bang Solutions, Thales and SMPP. So tomorrow, of course, we will, on the 20th, we will be organizing another session on futuristic technology for defense production, so at 10 a.m. So please request all of you to join in for this session on the 20th. We will see you. Until then, please take care. Thank you so much to all of you once again. Please take care. Thank you.